Welcome back to Mr. Hassan's Maths channel. I'm now going to be going through question number 5 from the February-March 2022 International GCSE, IGCSE Cambridge Paper 4, Variant 2. And this is from February-March 2022, as I said. And this question is all about statistics. And it starts off with giving us this frequency table. And they're telling us that the table shows information about the mass m in grams of each of 120 letters. Okay, letters meaning, letters in envelopes. Okay, people have forgot what letters are now because of all the electronic emails and everything. So it doesn't mean letters of the alphabet, it means letters where you post a letter to somebody. Okay, now. So you have 43 of those letters were between 0 and 50 grams. 30 of them between 50 and 100 grams, 25 between 100 and 200 grams, and 21 of them were between 200 and 500 grams. All right, so they're asking us to calculate an estimate of the mean mass of these letters. Okay, the mean mass of these letters. Now, to find the mean, what we have to do is we have to add together the masses of each of the letters. So you add together, find the total mass of all the letters and divide by the number of letters, which is 120, which they already told us. It's 120 letters. Now, the problem with this is we don't know the actual mass of any of the letters. I know there's 43 letters and their mass lies somewhere between 0 and 50 grams. But what are the actual masses of each of those letters? We don't know. That's why we have to estimate the mean mass. Okay, so what we do is we find what's called the mid-interval value. So we say, okay, there's 43 letters. They could be anywhere between just above 0 up to 50 grams. We don't know what they are, so we're gonna just say, let's just take what's exactly halfway between them, right? So we don't bother about that. That doesn't say equals and that does. We just say, all right, 0 plus 50 divided by 2. Halfway between 0 and 50, that's 25. Oops, what's happened there? That's 25. So there's 25 letters. So 43 letters, and we estimate their mass to be 25 grams. And these 31 letters, we estimate their mass to be 150 divided by 2, which is 75. That's halfway between 50 and 100. You add the numbers and divide by 2, it gives you what's halfway between them. Halfway between 100 and 200, that's 150, 300 divided by 2. And halfway between 200 and 500, well, that's 700 divided by 2, that's 350. So what we can do is we can say, okay, we can say, let's now find the total mass or estimate the total mass of these 43 letters. So they would be 43 times 25. 43 times 25 would be the total mass of these 43 letters plus 31 times 75 plus 25 times 150 plus 21 times 350. So that's the total mass of all the letters. All together, that's an estimate of the total mass of all the letters. And if we divide all of that by the total number of letters, which we know is 120, that's going to give us our mean. Now we have to be very careful when we put these numbers in our calculator, because it's very easy to make a mistake here. Okay, it's very easy to make a mistake here. So we have 43 times, let me just put it in one big fraction. So you have 43 times 25. So be careful you don't press the wrong button. Plus 31 times 75. Plus 25 times 150. Plus 21 times 350. Okay, and all of that divided by the total number, which is 120 letters, and that will give us the mean mass, which is going to be 120.83 recurring, 120.8333. So we should round it to, doesn't tell us how, so 3 SF, so that would be 121 grams. Okay, now, a few things that you should take care of here. Show your steps, because if you did make a mistake with your entering into the calculator, then, at least you're going to get the method marks. They'll see that you've got all the mid-interval values, you've done the right thing. Maybe you'll lose 1 mark for the answer mark, right? That's one thing. Secondly, check to see if your answer makes sense. okay, your mass has to be somewhere between these values, somewhere around these values, okay? You can see that the frequencies are kind of like more kind of heavily, in the lower end, because you've got 43, 31, then it becomes less there. So it makes sense that the mass is going to be somewhere towards the lower end between 0 and 500, but it's between 0 and 5. For example, if your mean mass came out to be, for example, 800 and something, for sure you've done something wrong. Right, so it has to be somewhere between these values, of course, between 0 and 500. Right, so that's another thing you can always check to just in case you made a silly mistake and put an extra 0 somewhere or something in your calculator. So always make sure your answer makes some sort of sense. Okay, so there's 5, part A. Calculate an estimate of the mean mass. Sometimes they ask you why is it called an estimate, and you would say that because we don't know the actual masses of any of the letters, so we have to estimate by using the mid-interval value, something like that, as we did. All right, so there's the answer to this question, part A. Now for part B, it says, Iraj draws a histogram to show this information. He makes the height of the first bar 17.2 centimeters. I'm going to take this diagram and bring it down. Okay, so what I'll do is I'll just take this diagram here. Let me move these out of the way. Oops, what am I doing? Let me move these out of the way slightly. Okay, so I got... drag everything with it. I should have prepared this before. I didn't think ahead. So I'm going to now just take a quick snapshot of this. Place it down here. Now, this will help us to... this will help us, okay? So in fact, I'll put this... Yeah, I'll put it down here. That's fine. Okay, this should help us now to figure out what to do here. Okay, now... Okay. All right, so now he draws a histogram to show this information. He makes the height of the first bar 17.2 centimeters. So the first bar, the height is 17.2 centimeters. You want to find the height of each of these bars. Now, a histogram is a kind of like a bar chart, except it's not a bar chart because it's not the height of the bar that represents the frequency, it's the area of the bar that represents the frequency. The height of the bar in a histogram is given the title frequency density. So we need to find the frequency density for each of these for us to be able to decide, the height of them, because it's a frequency density which determines the height of the bar. Okay, the height is proportional to the frequency density. So let's find the frequency density. Now, the frequency density is basically when you take the frequency and you divide it by the interval being how wide these groups are. So for the first bar, the frequency density is going to be 43 divided by 50. 43 divided by 50, which gives us 0.86. So there's the frequency density for the first bar is 0.86. For the second bar, we want to find what this is. Okay, I'll call this H2, H3, and H4, right? So for the second bar, we've got 31 divided by 50. Okay, so we have 31 divided by 50, which I think is going to be 0.62. Okay, that's 0.62. And then you have 25 divided by, this is 100. That's going to be 0.25. Okay, because the width of that bar is 100. And here you've got 21 divided by 300. So you have 21 divided by 300, which gives you 0.07. So those are the frequency densities for each of these bars. Now what we can do is we can just use simple proportion here. So the height of the second bar, I can just cross multiply. It's going to be 17.2 times 0.62 divided by 0.86. And the height of the third bar is going to be, using the same proportion, you're going to have 17.2 times 0.25 over 0.86. And the height of the fourth bar is going to be 0.07. Okay, so we can do the same way. 17.2 times 0.07 over 0.86. Simple as that. Okay. just using proportion. So if I take the calculator and I set this up, so I have 17.2 times 0.62 divided by 0.86. Okay, so it's all set up now. So you just do that. That gives us 62 over 5, which is 12.4. So that's 12.4. That's this one here. And for the second one, it's going to be the same calculation, except that becomes 0.25 instead of 0.62. So I'll just go back here and change that to 0.25. 0.25, oops. And that gives us 5. That's 5. And then for the last one, that becomes 0.07. 0.07. And that gives us 7 over 5, which is 1.4. So 12.45 and what was the last one? 1.4. 1.4. Just make sure that first one, in case I wrote it down wrong. Yeah, 12.4. Okay, just didn't write it very neatly. Okay, so that's simple as that. It's just using basic proportion, remembering it's not the frequency which determines the height, it's the frequency density which determines the height. So the height is proportional to the frequency density, so we can use the proportion that these give us to find out the heights of the other 3 bars. Okay, so there's part B done. Now for part C, it says complete the frequency table. Okay, so now we have, I'm going to just take this same table here and bring it down. Okay, just bring the same table down. So it says here, the cumulative frequency table. Now, cumulative frequency table, basically, it takes us all the way. It's like we're going to see the masses. We're having all the letters whose masses are less than 50 altogether. That's 43. Then this represents the masses, all the number of letters whose masses are less than 100 means from 0 to 100, from all the way back to 0 again. So it's going to be 43 plus 31, all of these together. Okay, that's going to be 74. And here you've got all the ones that are less than 200. So it's going to be all of these added together. So you're going to have 74 plus 25, which is 99. And then, of course, this is going to be 120, which makes sense. 99 plus 21. That's going to be the total for all of them altogether. So that is the cumulative frequency table. That one's sorted out now. So let me just, I think I'll need this for the next part. So I'm going to copy this. Okay, and I'm going to place it here because we have to draw the cumulative frequency curve, okay, on this diagram. So I need those values. So I'm going to just make a miniature version of that table and put it here somewhere so I can see as I'm plotting. So I have here 50 against 43. So I have to plot 50 against 43. So 50 is here and 43 is, that's 50. Okay, so that's 42, 44, 46, 48, 50. So 43 is exactly halfway between those two. So that's 43. Okay, then you have less than 100 is 74. So 100, I've got to go to 70, 72, 74. It's right there, exactly there. And then you've got 99 and 200. So we've got to go to 99. 200 first and then 99, 200. Okay, 200 is along this line here. 99 is just below 100, halfway between 98 and 99. And then we got 120 and 500, okay, which is, let's make sure this goes up to exactly 500. It's right at the last, right at the end here. Okay, so now we have all the information. Now we can draw the cumulative frequency curve. Okay, now the cumulative frequency curve, okay, is going to go something like this. Okay, so now to join these points together, as the cumulative frequency table from the beginning, it starts from 0. Okay, we could start from 0. We could start from 0, but we don't need to actually. Okay, we don't actually need to start from 0, but it's fine if we do. So we can start from 0 and we have to draw a smooth curve through these points. I'll start from here and I'm going to go like this, try to do the best I can. Oops, a bit wonky there. Now, you could leave it like that. I'll just try and make that a bit better. Okay. And because it starts from 0, you could go back to 0. You could go down to 0. Okay, that's fine. Okay. So now that is your frequency, your cumulative frequency diagram. Okay, where we've gone through the points that we plotted. Try to go through them as accurately as possible. Then it says, use the cumulative frequency diagram to find an estimate for the median. Now, the median is the middle value when things are placed in order of size. Okay, and because we're dealing with grouped data and it's like, not accurate, we don't know the exact values of the data and it's all estimated. So we're going to just take the total number, which is 120, and we're going to divide it by 2, which gives us 60. So we're looking for the 60th term. We're not thinking, all right, there's 120 terms, that's an odd, even number, that means there's 2 middle terms. We're not bothering about any of that because we're just doing an estimate here. We don't have the actual values. If we had 120 values and we wanted to find the median, we knew what every single value was. That's when you would say, okay, 120 divided by 260, that means we're looking for the 60th and the 61st entry. But here, because it's all an estimate, we just go to 60, okay, on our graph, and you should show your steps of how you did this. You go to 60, you draw the line across, and in fact, it's not even showing here because I'm using the same kind of, so just do this, going from 60, go all the way across to where it hits the curve, and then you see what value we end up with on the X or the mass axis. All right, so here we've got this is 50, okay, that's 60, 70, 80, 90, 100, so it's about 80. Okay, that's 80, 50, 60, 70, 80. It's around 80, okay, so the median is 80 grams. Okay, the upper quartile. Now, the upper quartile is like the upper quarter, you could say. So it's like 3/4 away along the data. So it's like you find 3/4 of 120, that gives you 90. So we got to go to the 90th entry. The 90th entry is right here. Okay, and we see what value it has. It hits the curve around that point there. Okay, it hits the curve around that point there. So we draw that line straight down from there until it hits the axis. So you're going to do this with a ruler. So that gives you 100. That's 150. So that's 160, 70, yeah, 160. So that's the upper quartile, 160. Okay, 160 grams. All right, let me just put that neater. Okay, and then it says the 40th percentile. So that's basically 40% of the way up. So it's 40 over 100, 40% of 120. Okay, so that's going to give you, that cancels with that cancels with that. 4 times 12, that's 48. So we've got to go to 48. Now that's 50, that's 48 here. 42, 468. 48 is around there. So we've got to go from 48 until we hit the curb, which is about that point there. And that gives us, that's 50, 60. So it's about 60 because I've drawn that slightly on this side. And so we could say 60, that's fine. Even if you want to put, say, 55, I think 55 would also work. It's a bit more close to that. I'd say between 55, let me say 57, all right? They're going to have a range of values. It's a very small scale, so I'm just going to put 57 because it's like close. It looks like it's a bit above 55, but that depends on how well we've drawn our curve. I don't think I drew it that well, so I'm guessing 60 would be okay. Then it says a number of letters with mass m where m is between 250 and 400. So now what we got to do is this time we got to go to the m axis and we got to go to 250 and 400 and see where those hit the curve. So I'm going to go to 250 first. 250. I'm going to draw a line going straight up, okay, until it hits the curve there. So this line straight up from there until it hits the curve. What's going on here? Okay, until it hits the curve. And another line from 400, same thing. And see, just draw that. Of course, you're going to use a ruler and a pencil when you're doing this. Okay. Oops. Sorry about that. I just sneezed. Okay, all the way up to there. And what we're going to do now is we're going to see what are those values on the cumulative frequency axis. So this is about around that point, and this is around that point there. Now we need to read off these values on the cumulative frequency axis. And here we see this value is about 100, and now each of these is 2 units. So it's 100, and that's about 103. And here you have, that's 2, 4, 6, 8, 10, 12. That's 14, so that's about 113. So we can see that the number of people in this category here is going to be 113 minus 103, which is 10. Now, your answers for these might be slightly different from my answers. Okay, and that's perfectly fine. If you look at the mark scheme, they don't actually give you any values for any of these answers. They give you, they mention that according to their graph. According to their graph, it mentions according to the graph that the person has drawn, because your graph might be slightly different. You might have joined these with straight lines, which you can do, or you might have plotted something incorrectly in your plotting part, but they won't take the marks off for these subsequent parts from that because it's all follow through. So basically, if you did your plot slightly different from mine and your answer come out slightly different, slightly different, there's no problem with that. Okay, there's absolutely no problem with that. As long as you have read the readings from your graph correctly with the correct scales and you've gone across, for example, you went across in the right places. Okay, so for example, here we went at 48 and here at 90 and here at 100 and, well, from here, from this side, those was, okay, from these values, I think it was from this value, yes, it was from 250 and 400, and then we read those values correctly, and the difference between them, that's perfectly fine. So that concludes this question number 5 from this February-March 2022 IGCSE Cambridge Paper 4 extended from the 0580 syllabus. Other questions from this particular paper will be found in the playlist, the link for which will appear in this region over here. Other questions from histograms can be found in this, like a playlist, all to do with histograms will be found in this link. And here, cumulative frequency, I'll put all the questions on that in this link. And you can watch the video here to help you use my channel to navigate through the IGCSE material more efficiently. Thank you for watching and see you soon.